Hey there, this is your host, Princess Jenna Ross, and beside me, the main character of the journey, Lily, and Be Her Best Friend, welcomes you to our discovery of science as we learn and enjoy. Join us as we deep dive into our fun science and stories journey. Today's adventure is about uncovering the hidden power of forces and understanding how motion shapes our world. Join Lily and Bee as they embark on a journey through the fascinating world of mechanics and discover the secrets of forces and motion. Together, they'll explore the concepts of push, pull, friction, gravity, and simple machines, gaining a deeper understanding of the invisible forces that shape our everyday lives. But that's not all. Throughout their adventure, they'll also learn about the different types of energy, including kinetic and potential energy, and how these energies transform and interact in the world around them. With each new discovery, Lily and Bee will piece together the puzzle of motion, revealing the incredible power of forces and the beauty of the natural world. So sit back, relax, and let the adventure begin. Chapter 1: Forces Make Things Move. Lily loves building things. She's made a house for her teddy bears, a rocket ship for her action figures, and a castle for her dolls. But now she wants to build a cart for her favorite doll. She and Bee have a plan. First, find for sturdy boxes and arrange them into a square. Then they cut a hole in one side of the box to fit the doll. Next, they drew a face on the front of the cart and decorated it with stickers. Now it looks just like a real shopping cart. It's time to test it out. Lily said to Bee. Lily sits the doll in the cart and gives it a big push. The cart moves forward. She lets go and the cart slows to a stop. Bee crawls behind the cart and pushes it from behind. The cart speeds up and moves faster. Then she stops pushing. Again the cart slows to a stop. Lily and Bee look at each other, puzzled. How do you make the cart go faster? Bee asks. Let's try again, Lily says. This time, she pushes the cart harder. To her surprise, this time it goes faster. Changing how hard you push or pull something is called force. The harder you push or pull, the faster something will move. If you want to make the cart go faster, you need to use more force. If you want to make it go slower or stop, you need to use less force. They continue to play with the cart, pushing and pulling it in different directions. Pushing makes the cart go forward, pulling makes the cart come back. They even take turns pushing and pulling the cart together. Look, we can make it go round and round. Lily giggles. But they wouldn't be able to make the cart move at all without another kind of force, friction. When the cart isn't moving, friction between its wheels and the floor keeps it still. When Lily and Bee push the cart, they're using force to overcome friction. Friction is an unsung hero of motion. We usually notice it when it makes things slow down or stop, like when a toy slides off a table and hits the floor. But friction is helpful too. Without friction, we couldn't walk or drive or even hold things in our hands. It takes friction between your feet and the ground to help you walk. Friction also makes it possible for us to grip a steering wheel and helps keep our cars on the road. Chapter 2: The Secrets of Motion. After playing with the cart, Lily and Bee start racing around the room. Whoa. You're so fast, Bee says, gasping for breath. Let's race outside, Lily suggests. They raced a toy car across the lawn. Then they raced a bigger cart. Still, Bee was faster than both. Lily wonders why. Bee says, remember when we raced the cart inside? I pushed it really hard and it went really fast. By pushing harder, I increased the force. I'm pushing with a lot of force right now. You push and pull to change the speed of an object, Bee explains. Yeah, and the faster something goes, the higher its speed. That means you're moving really fast, Lily says. Yep, because I'm moving really fast. I have a lot of kinetic energy, which is stored energy of motion, and changing direction needs force too, B adds. Like when I turn the wheel of the cart, I need to push to steer it, which is why you have to turn the steering wheel to make your car change direction. Chapter 3, Energy All Around Us. One evening, Lily notices how dark it's getting outside. Tomorrow I want my garden to be all lit up, she tells Bee. But it's too dark for solar lights, and there's no way to plug in electric lights. Can you think of a way, Bee? Asks Lily. I bet we could collect energy from the sun during the day and use it at night, like how my wings store up energy from the sun, Bee says, but that takes all day. Is there any way we can get light without waiting? Sure, you could rub your hands together. Bee demonstrates. Wow, they're really hot now, but the friction makes me slow down, so I'm losing energy. Are you sure that's energy? Lily asks. Yes, energy is anything that can make things happen. Like when you eat, you're turning chemical energy from food into movement. Everything that moves or makes something else move has energy. Chapter 4, Kinetic and Potential Energy. Lily and Bee are playing outside. I bet I can roll my ball all the way to the top of that hill, she says, but the ball rolls halfway up and then it rolls back down. Why doesn't it go higher? Because you gave it only a little push, Bee says, so it didn't have much kinetic energy, which is stored energy of motion. It turned most of that energy into potential energy, which is stored energy of position. Wait here and I'll show you, Bee calls. She scoots ahead. Just before the ball reaches the top, she says, at the top, the ball has the most potential energy, but the least kinetic energy. When it starts rolling back down, its potential energy becomes kinetic energy. Whoosh! Bee shouts. The ball is speeding up. At the bottom, most of its potential energy is now kinetic energy. But where did the rest go? Most of it became thermal energy, heat. If the surface were rougher, more would turn into sound. Energy can change forms, but it's never lost. A swing climbing higher and higher has more potential energy. A stretched rubber band has potential energy. A bouncing spring has potential energy. All of these examples have potential energy. Chapter 5, The Power of Friction. Lily and Bee are playing hide and seek. Come find me, Bee calls. Lily runs to find her friend. Suddenly, her feet slide out from under her. Whoa! Lily shouts. She looks down. The floor is shiny and smooth. No wonder I slipped. Bee says when surfaces are smooth, it's hard to get a grip. Like when I tried to walk on ice, I kept slipping and falling. Friction makes it easier to stay upright on the smooth floor. Friction isn't helping her move, and Lily is having trouble staying on her feet. Bee says sometimes friction makes things slide around, like when a book slides off a desk. In that case, friction is making the book speed up. If there were no friction, the book would just keep sitting there. In general, though, friction slows things down. If you want to make things go slower, friction can help. If you want to make them go faster, friction will probably slow them down. Chapter 6, Gravity's Gentle Hug. One day, Lily finds a bag of balloons in the attic. This would be fun, she says. She inflates one with air and ties it securely to a chair leg. Take a deep breath and blow out the other end. She lets the balloon go and it floats up, up, up. It hits the ceiling and pops. Another one, this time. She ties 2 balloons to her wrists. She closes her eyes and wishes she could float away. Just then she feels something pulling her arms down. Gravity, Bee says, everything has mass, and anything with mass has gravitational pull. Earth is big, so its pull is stronger than the pull of other objects. The balloons might float away from you, but they're still close enough to Earth for gravity to pull them down. Earth is like a giant magnet that pulls everything toward it, which is why the universe is shaped the way it is. Chapter 7, Simple Machines Save the Day. Lily sees a huge basket of laundry on the stairs. How can I get it upstairs? She asks Bee. My mom uses a ramp to get big pots of soup onto a high counter. A ramp makes it easier to move things up a height. Pulleys make it easier to move things a distance. This pulley system lets you lift heavy loads with a lighter pull. Here's how: instead of lifting the entire weight of the basket, you're lifting a smaller part of it, the rope. If you want to lift a heavy load, you can use a machine. To make it easier, machines don't give you more force, but they make work easier by changing how the force is used, like how a ramp helps you push an object up a height or how a pulley helps you pull an object up a distance. Chapter 8, The Magic of Magnetism. Lily's toy train is stuck under the table. How can I reach it? She asks Bee. A magnet can reach it. Bee pulls out a powerful magnet and pushes it under the table. Hey presto, the train flies out. A magnet can attract certain metals like iron. The train is made of metal, so the magnet's pulling it out from under the table. The magnet's invisible for sacks from a distance. Magnets have north and south poles. Opposite poles attract each other, like poles repel each other. Attraction and repulsion are examples of magnetic force. A magnet has a magnetic field. It's an area where magnetic force can be felt. Magnetic fields are always invisible, but they can be made visible with special materials. These glowy lines show where the magnet's force can be felt. Magnets are invisible helpers in many devices like motors, generators, speakers, headphones, and more. Chapter 9, The Dance of Light and Sound. After a summer rainstorm, Lily and Bee are playing outside. Look, there's a rainbow, Lily shouts. It's amazing how light can be separated into all those colors, Bee says. Sunlight is made of all the colors of light, but light can do more than make pretty rainbows. When you shine a flashlight at a wall, the light bounces off the wall and into your eye. You see a brighter spot. But if you turn off the lights and clap, you hear a bright echo. Sound travels in waves. Light travels in waves too, but we can't see the waves. Sometimes we feel them as warmth. We call that infrared radiation. Sometimes they're so tiny we can only see them with a microscope. Those are called gamma rays. Visible light is just one part of all the types of light. And while we can't hear the waves of light, we can hear the waves of sound. Chapter 10, The Top of the Science Pyramid. As the sun sets, Lily and Bee sit on the porch steps looking at the sky. Today was an exciting adventure, she says. You know, when we pushed and pulled the cart today, we learned about forces and motion. Then we discovered that faster means more energy. We saw that energy can be kinetic or potential. We figured out how friction helps or hinders motion. We experienced how gravity pulls everything toward Earth, and we learned how simple machines help us do work. We explored how magnets attract and repel, and we learned that light and sound travel in waves. Everything is connected, Bee says. It's like a science pyramid. Everything we learned today fits together. Lily smiles. We climbed one step at a time, and now we understand more about the world. They stand up and walk toward the house, ready for a new day of adventures. Once again, this your host, Princess Jenna Ross, as well as Lily in the Science Story. Thanks for joining us and see you next time.